For this problem, for the first one, the resultant of two forces in the plane is 400 newtons at 120 degrees. If one of the forces is 200 newtons at 20 degrees, what is the other force? So let's construct our force triangle. First, we draw our first force vector that is acting at an angle of 20 degrees from the initial side. It has a magnitude of 200 newtons. Now connecting head to tail, we can produce our second force vector acting at this side here with an unknown magnitude of f. We can produce our resultant force vector by connecting head to tail that has a magnitude of 400 newtons acting at an angle from the initial side of 120 degrees. Now if this angle right here is equal to 120 degrees, therefore this middle angle here is equal to 120 minus this angle here, 20 degrees, equal to 100 degrees. Now we've constructed our force triangle. To solve for f, we can utilize the cosine law of triangles. So f squared is equal to the sum of the squares of the other two sides. That is 400 newton squared plus 200 newton squared minus twice the product of the other two sides. So 2 times 400 times 200 multiplied by the cosine of the opposite angle. That is 100 degrees. So we can solve for f by taking the square root of 400 squared plus 200 squared minus 2 times 400 times 200 multiplied by cosine of 100 degrees, which is equal to 477 newtons. That is letter A. For the second problem, which is not true about two forces in equilibrium, the answer to this is letter B. Two forces are perpendicular. The reason for this is that for two forces to be in equilibrium, they must satisfy the three conditions. First, they must be equal in magnitude. The forces must balance each other out, and they must be opposite in direction, so the two forces will cancel out each other. And they must also be collinear, so that they act along the same straight line. So we can represent this by drawing two forces that are equal in magnitude and acting in opposite direction, so that these two forces will cancel out. For the third problem, what do you call a force that is equal to the resultant force, opposite in direction, and collinear in action? This is called the equilibrant force, which is letter B. It is a force that balances that resultant force. It is equal in magnitude, opposite in direction, and collinear with the line of action of the resultant force. This makes the equilibrant the correct term for such a force.